Hey everyone, how are we doing? We got Reese here, we got Tara here, we got Kayla here. I don't think Mewbot's awake. Oh, he is. He's been awake in the background this whole time. There's a hair on my microphone or in front of my face, just things everywhere. Chem was awful. I'm so sorry to hear that. What questions do we have? We could go over some interpretations. I think that might be a big thing that people are wondering about. Definitely studying for two files today, but I want to stop by and say, oh, you're welcome, Ashley. Thank you so much. Ashley, we'll throw some points here. Ashley, love the positivity right there. Sorry, Reese Mewbot's waking back up here in the background. No, thank you. Like, it's not my work, it's your work. Like, we're here working together on this, and thank you so much. Chi-square, should do some chi-square. Chi-square, the last thing we talking over some of those chi-square results. Let's throw out some 500 points. I'll be sending out a form for you to enter in your points. Compared to the last two exams, how hard? I think it's on par with the second one, but it's very repetitive. This exam, you either kind of know it or you don't. If you don't know it, you're like, what the heck are we doing with these tests? So let's actually jump into it and start doing a test. So chi-square is a great thing to go off of. I'm going to load up some jump here in the background. So no, it's really everyone tough. Like this is not the easiest. This is not the easiest class. Like when it comes to difficulty of class, I'd say is like a 5 or 6. It's not a walk in the park class, but it's not like your organic chem classes, I would say, at least in my opinion. Once again, this is based off of my view on it. So when it comes to it, I understand that it can be very challenging for people. And hey, Zaid, great to see you here. So if you make a B+, if you make an A-, don't worry, be proud. This is definitely a class where we have pretty high expectations. Jazzy is in attendance today. Oh, Tara's cat. She's more focused on my mac and cheese at the moment. Morning, Jazzy. I seen 88 Vincent. Let's try to make that happen. Here, Vincent was asking about some chi-squared. Let's go over and talk about that chi-squared. Here we go. Chi-squared stuff. Starting right up. So, I had to move my camera because we're getting a little bit of, as the night progressed. Okay, there we go. I'll move the camera a little bit. It's bothering me there. It is doing that. 2 seconds here, everybody. Green screen stuff. It was the keyboard was casting a very small shadow on the green screen, causing non-perfect green screening, and we can't have that. Okay, so when we do the chi-squared test of independence, what kind of data are we going to use? When we do the chi-squared, I can't do that, but it'd be pretty fun if I could, right, Vincent? Aloha, Diddle, good to see you here. What kind of data are we going to do for the chi-squared test of independence? This is an important question. I think a lot of people just think, well, let's just make one. What are we going to do? 2 categorical variables. Great job, Killer, right there, 100 points. 2 categorical variables are going to be for the chi-squared test of independence. So categorical data, which means we can actually eliminate it down going here, removing out the numeric, and just doing these things. So what do you want to do? Tell me the 2 numbers you want to do, like 26, 29, like, dude, humans on Mars, whoa. You have to look to the variables to get the joke. So what do you think we should do? Which 2 variables should we look at? Ahoy, Sam, good to see you here. I feel like I should think 29 for sure. And okay, there we go. 29 is in the X. And 14 is your major. Now, this is going to be a mess. I'll show you it, but it's going to be a mess because major has way too many levels. And so, whoa, we might actually probably, oh, wow, I've never seen them that divergent. The piercing comes back not significant. Water habit, what do people drinking? So this one right here, we would not put on the test. There's way too many levels to major. It kind of acts like an identifier right now. Little old decision tree stuff right there. We do see some differences. It's funny, one test comes back not significant, the other test does. I could go into more detail on that. That one's kind of data's not totally cleaned right now, so we might not do that one. People are saying water habit. Which one's water habit? I'm so blind. Tell me the number on water habit. My eyes can't find it. Water habit's 34. There, my eyes can see it now. Let's go ahead and take a look. Now, you should kind of know right here. So this is whether or not someone has smoked weed and their water habit. So what do you notice? Is there a difference between, let me just ask this flat out, yes or no to start. Is there a difference between people smoking weed and their water habit? Is there any differences? Are there any differences? Just a simple yes or no to this. Are there any differences between people smoking weed and their water habit? Are there any differences? Yes or no? Simple question. Just yes or no. Are there any differences? Are there any differences? Yes or no? So, I'm not on live chat yet. Yes or no? Kayla, and so don't worry, Catherine, there are some differences. There are some differences. Do you see this right here? That's a difference. There's a difference. So I understand people are saying not really. Like that's what we're probably going to come to that statistical conclusion. More on that in a moment. But just mathematically, and Reese is right there. Great answer, Reese and everybody. We're throwing 100 points. You know what? I'm throwing 100 points, 500 points to Catherine right there. Don't worry about answering first. People are saying it's small. That's the exact answers I'm looking for. And we'll talk more about how small they are and how likely they are by something in just a moment. But let's start out here with the null hypothesis. And I kind of want to get into some writing conclusions. I want you to try writing the conclusions because we do have you write conclusions on the test. So if you're here reviewing right now and you're doing this, I want you to try to write the null hypothesis. So when you think about the chi-squared test of independence, there's one important word we'd like to use, and that is the word independent. That word independent just goes right here between the two variables, and this is your starting out assumption. So we haven't run the test yet. We're just thinking about what the test would start out with as a null hypothesis. So what would be the null hypothesis starting out here, the starting initial assumption? What would we do? Try writing that in the chat. Once again, this is reviews for you. I can go through all the answers, but I want to jog your memory and have you thinking of these things to be like, okay, the null for this test is this, the starting assumption. Perfect right there. And you just put the word independent, like smoking weed is independent of a person's water habit. And it came up on the Discord. Great answer. And Kayla, thank you so much. Kayla's answering tons of questions on the Discord, getting to them before I can. So I'm just like, Kayla's right. Water habit is independent of smoking weed. You can switch it around. X is independent of Y. Sometimes we like to put the X in a certain spotlight. And Sam, great job there too. Smoking weed is independent of a person's water habit. So if they are independent, and that's what we just said a second ago, knowing if somebody smokes weed would tell you nothing about their water habit. Like if they carry a refillable water, if they do these different things right here. So when you look at this, I want you to think about how these differences look. And you just said they look small, right? So if someone was like, oh, dude, the people who smoke weed are all about purchasing water. Like the more of them purchase water and more of them drink directly from a water fountain. These differences right here, because there are differences, are very small, and thus those differences are likely by, put that word, just the first word of it, and then the second word, are likely by this chance. Like those are very small differences. Those are very small differences. We're just kind of jumping to interpreting the results here. Like this is what we'd usually do in statistical analysis, random. So those differences are very... Music didn't stop. Those differences are very small and likely by random chance. So what do you expect the p-value to be? Just tell me one of those two. Since these differences are small between this, you probably expect the p-value to be very what? Since the differences here are very small, thus likely by random chance, you'd probably expect the p-value down here, which we'll look at in a second, to be very what? You'd probably expect the p-value to be very what? This is a good review of interpreting the results, which you will have to do interpretation of results. And I'm going to tell the graders to rush on this one. I'm going to say, please have this graded as soon as possible. And so I'll state, Casey, good question right there. I'm going to state the conclusion in full on this. I'm going to do that right here. We'll see the p-value here in a second. But since these differences are small and thus likely by random chance, we'd expect the p-value to be very what? Like I see very small differences that look likely by random chance. I'm buffering. Not statistically significant. Very high because they're very likely. And it's not as the buff is bad. No. I don't know why we're buffering. Very large p-value. A large because they're likely by random chance. Wow. We look like we're good now, right? If you can find me a new internet provider in... I've looked, and it's like our area doesn't have it. If you look at College Station, Texas, we're part of like where Suddenlink is at, and we can't get like other services. Like they're like, this area can only have this service. And I'm like, why can't AT&T just give us service? So when we have a high p-value, high p-values are likely by random chance. Does that make sense to say what we saw up here? So let's state our conclusion. Remember, I don't want to write these things out. Giga Maggie's. Some Tara knows some College Station. So I don't want to write this out. I want you to try writing it out, and then I will state it. Remember, we are testing to see if somebody's water habit is independent of them smoking weed, either which way. So I want you to tell me, I do what right here? Look at the p-value. Pearson has your p-value. Awesome. Sorry about the buffers. P-value down here, look at it, and write your... pretend this is the test. I will grade it out of 4 points. My graders might be nicer than me. You can always debate your grade when you see it. If you're like, Brian, I think they took off too many points. I'll never take off more points unless they completely misgraded. Like if they give you like a 90 on the test and you got a 40, I'll have to be like, is something wrong there. It's probably a lot of schools are like that. Try writing your conclusion like this is a test question. If you're watching this video in the future right now, it's like Wednesday night, try writing it down. Pause the video right now. Fast forward to the part where I'm doing it. I'm going to raise my hand when I do it. So try doing it. People are going to try writing in the chat. This is where you can practice and see if you get something close to what I say. And I can also grade it in the chat if you like. I'll probably be telling you my thoughts on it, but come to your conclusion on this. Come to your conclusion. What would you state? So what would you state right here? And my graders are probably going to be a little bit nicer than me. I'm going to be very exact in what I say, because some of the things might tell you to use an alpha level, so we'll assume a usual alpha level. If you didn't mention that, that's all right. Test questions might tell you use an alpha of this, so you should probably mention that. Oh, gosh. Oh, wow, Tara. That's the tour. It's a good practice right here. Who can write it out? I failed to reject the null hypothesis that water habits are independent of smoking weed. I have no evidence that water habits are not independent of smoking weed. That, Casey, right there, and aside mentioning, so here's what I would do also. Casey, that could be 4 out of 4 points. What I would also do, that great answer, Casey, 100 points. So what I would also do, yes! Let's throw some 500 points to Casey right there, beating me to it. I think she was like, wait, I'm going to add in this extra. That's a good thing to add right there. Mentioning your p-value, since my p-value of 0.2578 is above the alpha level of 0.05, I fail to reject the null hypothesis that they are independent. I do not have evidence for the alternative. And this is, Casey literally gave, let me raise my hand and read Casey's answer right there. So I'm going to read it in full, and this would be the A+ answer. So great job, Casey, right there. I'm just holding my hand up if people are like, what segment is he talking about the answer? So since my p-value of 0.2578 is above the alpha level of 0.05, and that's the assumed default alpha level unless otherwise stated by questions. Questions may tell you to use a certain alpha. I fail to reject the null hypothesis. P-value high, let the null fly. Don't put that part in. That water habits are independent of smoking weed. I do not have evidence for the alternative that they are not independent of each other. So right there, that's top tier. Casey, amazing work. If you wrote that out as your conclusion, especially with adding in your p-value and your alpha, that's the big things we need right there. Like, okay, the p-value above alpha is how we decide to reject or fail to reject. Definitely start, like here, let's go to a Word document just so people can see it. So one, stating or conclusions on nulls/alternatives. I would probably start by immediately state your p-value and if it is above or below alpha. It's about as much as I can teach the test right there. Yep. Yeah, exactly. So when you're stating your conclusion, as Casey did right there, start by mentioning your p-value if it's above or below alpha. If it is above alpha, talk about failing to reject the null and not having evidence for the alternative. So you have to know the null and the alternative. If it is below alpha, talk about or at or above. If it is at or above alpha, because you have to be below alpha. At or above is fail to reject. If it is below alpha, talk about rejecting the null and having evidence for the alternative. Everyone, thank you so much, everyone working so hard. We've all been working hard, and I really appreciate it. That's why I want to be on here. We did that 8-hour stream. I think that zapped me. I kind of took yesterday off a little bit. I was like, I'm going to sleep. So state your p-value as Casey did right there to mention if it's above or below alpha. And then if it's at or above alpha, which Casey noticed, talk about failing to reject the null hypothesis and not having evidence for the alternative. If it's below alpha, talk about rejecting the null and having evidence for the alternative. So a good thing to do here. Well, first off, let me ask you, how many degrees of freedom does this test have? Nice and easy question. If you get a question like this on the test, you're like, boom, we can just crush that question. So look at this graphic right here and just inform me, how many degrees of freedom does this have? There are written interpretations, hence why I did that right there. There are written interpretations for confidence rolls and tests. Zaid, great job. I think you're right. Double check. Double check. No, I looked too quick at the 4. There are 3. Brian, this is a great job. Muhammad and Kayla right there. 100 points right there. And Zaid, don't worry. We're throwing Zaid another 500 points right here because, once again, don't worry about being first. Put those answers out there. You're practicing if you're first. And if you get it wrong, you'll be like, wait, what did I get wrong? Oh, and then when you get to the test, you'll remember it. That's the point. We get things wrong in class to get them right on the test. The more you get wrong in the class, the more you find what you need to just practice. Quick mistake. Brian, this is a what by what. Be very careful. Brian, this is a what by what. I don't want to give you the answer. I want you to think about it. Brian, this is a what by what right now. So how do we do degrees of freedom for the chi-squared test of independence? Exactly. It's a 4 by 2. So since it's a 4 by 2, drop each finger and you get 3 times 1. So it's a 4 by 2. We're saying 4 because there's 4 categories to drinking water habit. Do not include the totals. And then there's 2 categories to whether or not someone has smoked weed. And there you go. It's 3 times 1. Easier question right there. And you can see the degrees of freedom down there on the bottom. Great job, Reese, practicing up right there. So those are the easier, like, you get that on the test. You can still make a mistake. I've made mistakes. Truthfully, I saw Zaid's answer. And Zaid, you do such an amazing job. I was like, that's right, 4. Oh, wait a minute. Like, I truthfully saw it. And I was like, Zaid's always right. But don't worry. You got this. Like, we all make mistakes. You see me make mistakes on my Pearson all the time. So don't worry about it. Forget about it. So we say in New York. So we'll do one more right here because let's try to get something that is significant, unlikely by random chance. And so we're going to go here to smoked weed again. And let's go to... Let's go to social political view. Yeah. Now we see... Yeah, we do. Okay. So now you notice that people who have smoked weed. Now, here's the thing. The majority of people who have and have not are mostly what? The majority of people who have and have not, the majority of them are mostly what? And actually, you know what we need to do? Let me fix this variable. So I'm going to do something real quick to this because it looks weird. And I'm going to go here to social political opinion. Where's it at? Social political view. Here we go. I need to fix it. Value order. Okay. It's out of order. That's why I'm like, wait a minute. Okay, very liberal. Okay, there we go. Apply. Okay. And then redo analysis. Okay, now it's in order. Okay. So the majority of people, this is a little bit better right here, a little bit easier to see. So now, oh, wow. I was trying to full screen it. Okay. The more people are in which group for each? Moderate people are saying in the chat. Great job. More people are moderate, but it looks like people who smoke weed might be a little more likely to be this. Like if you had to tell me the relationship right here, like we're really seeing a shift in the distributions of people who have smoked weed that they're a little more likely to be this. Now, most people are moderate, and we can't say, well, conservatives don't smoke weed or haven't smoked weed. Well, you got a lot of people who have smoked weed and are conservative or even very conservative. But we see a little bit of a shift towards this given someone has smoked weed. Given someone has smoked weed, they're a little more likely to be this. When you look at the shift in the distribution, the way it goes. Like here's the distribution of people who haven't smoked weed, and then here's the distribution of people who have smoked weed, and you see a little more of a shift towards what as you look at the two right here. Like the association looks to be like, it's more likely someone would be what given they've smoked weed. Like a little more likely this. Probably your best guess is someone's moderate. You're like, what are you? More likely you're moderate. Like a lot of moderates, a lot of conservatives too. But you see a shift towards this given someone has smoked weed. Like there's the association goes in this direction. They're more likely to be liberal. You see a growth in these categories going from the not smoked weed to the have smoked weed, a growth here where of the people who have not smoked weed, only 18% of them are liberal. Of the people who have smoked weed, 27% of them are liberal. And then you see a big growth here in the very liberal. So, and then over here, you see the very conservative shrinks down. There are people who are very conservative. That is 17 individuals in our data set out of the 806. So there's 17 individuals who are very conservative and have smoked weed. So you can't, once again, don't assume things about individuals, but there's a trend in the overall data. That's what we're pointing towards. So it looks like there's an association. Now, I'm saying it looks like there's an association. You can't just look at graphics. If I'm saying it looks like there's an association, I would expect to see a what p-value. Like if I'm thinking just in my having viewed this with the mosaic plot, I'm thinking it looks like there's an association. I expect to see a what p-value now. Like, don't just be like, well, it looks like there's one, so there must be this. Just going off of what we would think given there is an association. If there is an association or evidence of one, the p-value is going to be low. And that's what we see down here. So you're kind of making sure you understand like the concept of what we're looking for. Remember in our previous graphic, which I think I still have up, we saw what looked to be just differences due to random chance, and we saw a high p-value. These were small differences. Compare that now with our graphic over here. I don't know if I can get them both on the screen at the same time. There we go, almost. Comparing the two graphics, these differences in the first graphic are very small, and the differences in the second graphic are very large. So the first one has a high p-value because those are just likely random chance differences. So we think there's a lack of an association. Oh, I see what Zaid is saying exactly. Association is not independent and low p-value. That would, yeah. And so check it out right here. So take a moment, see if you can write your conclusion. We'll just put on our chill music. So try writing your conclusion right now. I don't think I have the music playing. Oh, I do. Write your conclusion. Give it a moment here. See if you can write your conclusion for this. And we'll do some conceptual interpretation next. Who can write the conclusion? This is your time to practice. This is our time down here. Can you write a conclusion for this? I'd love it if I could get someone who knows like all ins and outs of streaming to help me optimize. I wonder if there's a way I could not have the buffers. I know a lot about streaming, but I just stand on the shoulders of giants who those who teach me how to stream even better. Trying to make that Pokemon Stinger intro. Got to work on that maybe this week. What is your conclusion? What is your name? What is your favorite color? Basically, now remember, Tara, good answer, Tara, good answer. But let's start. Oh, and then Mohammed will go back over that. Good question, Mohammed. So start by stating. I don't know. And Zaid, state those things. Make sure to state those things. So let's see. I think Casey knocked out of the park again. So Casey at bat right there. William got it. So start by stating your p-value and if it's at or below alpha. So start with the first step. My p-value of what? Just type your p-value in the chat right now. Type your p-value. Oh, no worries, Tara. This is the practice. This is good stuff right here. Tara, 100 points right there. My p-value is this. Just say my p-value is this. Just someone put the p-value in the chat. Be like, my p-value is... what is my p-value? Like, tell me your p-value. Boom, right there. Catherine got it. My p-value is 0.0001. I think it's that extra O. And that means it's actually below that. That's what that little star means. My p-value, and you can probably just say that, is below this. Below 0.00001. No worries. It would probably be like, yeah, it's fine. And thus it is below my alpha of what? Now, what is the assumed alpha? So my p-value of 0.00001, below that, is below my alpha of what is assumed alpha, unless otherwise stated. 0.05. Great job, Tara, right there. Great work. My p-value of 0.0001 is below my alpha of 0.05. Thus, I what? Thus, I what? Thus, I what? Just, thus, I what? Thus, my p-value of 0.0001 is below my alpha of 0.05. Thus, I what? I reject the null hypothesis. So I am rejecting that smoking weed is independent of somebody's social political views. I have evidence of a what between somebody smoking weed and their social political views. I'll repeat the full thing again after this. Try writing it out too if you want. I reject the null that smoking weed is independent of somebody's social political views. I have evidence of a what between somebody smoking weed and their social political views. I have evidence of a what. I have evidence of and you could say this, you could say that they're not, I don't know. I'll let you think about it for a moment. I have evidence of association. Ditto, great job. Ditto joining, I think. I have evidence for the alternative that they are associated. So and make sure to say what the alternative is to the reader. Like I have evidence that there's an association, which is the alternative between somebody smoking weed and their social political views. Like knowing somebody smokes weed would give you information about their political views. Does that make sense right here? I'll repeat the full thing. So the full interpretation is my p-value of less than 0.00001 is below the alpha level of 0.05. Thus, I reject the null hypothesis that smoking weed is independent of somebody's social political views. I have evidence of an association between somebody smoking weed and their social political views. Does that make sense to everybody right there? So we reject the null hypothesis and we have evidence for the alternative, but you also want to state to the reader what those nulls and alternatives are. So you want to tell someone in context, like let's add that to the sheet right here. Always use context. So that's everything for confidence intervals. For everything, you have to be in context and be like, I mean, if I'm going to summarize this to a boss, I'll type the full thing out. So here's the full thing. Thank you for asking, Kylie, right there, 100 points. Always ask these things. I think Mohammed had a question too that I need to get back to. Thank you, everybody. Ask all those questions. You know how we roll here. Just ask the questions. We'll work on it. So my p-value of less than 0.01 is smaller than 0.05. Thus, I reject the null hypothesis that smoking views. I have evidence for the alternative that smoking weed is associated with someone's social. There we go. I think maybe since my p-value of 0.01 is less than my alpha level of 0.05, I reject the null hypothesis. There is evidence that it's smoking. Literally, Trevor, 500 points. Trevor, I think you literally typed out what I was typing out. Take a look, Trevor. How's yours look to mine? Because, yeah. Can we go over the type of questions we might be asked about yeah, we'll do that here next, Casey. Definitely. Let me look. Mohammed had a question. Trevor getting some 500 points for everybody. Thank you, Trevor, typing that out. That's the practice we want right here. I think you literally have nearly identical to what I have, and that's when you know you're on track right there. Great job. Mohammed asked, can you please explain one more time, how do we know if it's a small or large p-value? So when we see small or large p-value, this is Mohammed's question, small p-value means it's unlikely by random chance, and large p-value means it's likely. Congratulations, Kayla's husband. You know what? These 500 points go out here to Kayla's husband. So there's 500 points to Kayla's husband right there. Specifically only for him. No one else gets those. I can't control that. His name is Trevor. Hello, Trevor. Hope you're having a great day. I love it. We got cats watching. We got husbands watching. That's the way we roll right here. So if we had, I want you to think about this sort of thing. I didn't do this example this semester. I should have done it. So how would you feel about studying if I told you these are the students who fail the test and these are the students who pass the test? These are the students who study. These are students who do not study. And so how would you feel about this? Best name, Trevor? Yeah, Trevor. I'm partial to Brian. How would you feel about studying if I told you this is the way it looks? I've looked at the data. These are the percent of students who fail the class who study. These are the percent of students who fail the class who do not study. How would you feel about studying right now? How would you feel about your time you're currently spending? And this goes to Mohammed's question. How would you feel about your time spending if I show you this graphic? You'd be like, you'd ask The Rock about studying, and he would say, it doesn't matter. Mohammed knows what's up right there. Mohammed 100 points. It doesn't matter. It doesn't matter because you're like, well, study for the exam, probably fail it. Don't study, probably fail it. So these differences right here between not studying and studying are probably due to random chance. I reset the computer recently. So the p-value here would be, actually, it would be this. Does anyone know the value of the p-value? Because this is the most likely thing to see by random chance. So since this is the most likely thing to see by random chance, the p-value here would be what? And you are right, Trevor. How high? It's the most likely thing to see by random chance. By random chance, if there is no association, this is the most likely thing. Oh, we could do that here in a second, Reese, too. You got it. And Zaid's right there. It'd be 1. It'd be 1 specifically, not 0.1, but it'd be 1. It'd be 1 because it's the most likely thing to see by random chance. Does that make sense? Like to say this is the most likely means 100% of results will be at or more extreme than this. Like this is the highest possible p-value and the most likely thing to see. So what would be something that's the least likely to see? And this kind of goes to the idea of expecteds. Hopefully we see something like this. Now, the fail rate on the exam 3 is usually something like this if we average the 2. But we have here, no, I reversed it. There we go. Studying and not studying. So we see something closer to this. People still fail the exam who study. But what do you notice right here now? The first one would have a p-value of 1. So this p-value here equals 1 on this because it's the most likely. If there's no differences. Now with the second one, there are differences. Notice here how there are differences between these two. And would you be like, I don't think it's studying. Like, we can't say studying causes people to pass the exam, but is studying associated? Like, you know someone studied for the exam, would they be more likely to pass? You know someone studied for the exam, would they be more likely to pass? Just looking at the data right here on the second graphic. Knowing somebody studied for the exam, would then that give you information worth it this time exactly? So then they're not independent because independent means if someone didn't study or studied, it tells you nothing about whether they passed the exam. So on the second graphic, we see evidence of an association. Now, we can't say if you study, you will pass. We can't say studying causes people to pass. Watch out for those cause words, prove word, accept word. Statistics is all about evidence. We try to say, is there an association where people who study are more likely to pass the exam? That is a true statement. Now, why it happens, we can't say. We can't, because maybe people who study are just better students. I'm not saying, we don't know. It could be, we could have someone not study who's a good student. They pass because maybe they go to class. Maybe it's go to class. People go to class. And so, funny I will throw 500 points. If anyone knows the name, Ditto might know because they're in the FLO classes. What do we call these variables that are outside the model that might actually be the influential variable? I don't think it's on your stats one, but it's such an important concept because we haven't controlled for them. 500 points on the line right here. Who knows what variables we talk about that are outside a model that could be the true cause of the variation? Not quite outliers. Outliers would be influential points. But if there's a variable, like maybe it's people going to class, and people go to class are more likely to study. It doesn't start with a V. It starts with an L. Good guess right there, Kayla. Good guess. Starts with an L. I'll give it 10 more seconds. Just powering back up with some coffee right here. Lurking. Zaid getting everyone. Yep, Kayla got it too. Lurking variables. And they're variables outside the model that might, and that's such an important concept because you can't say, unless you do an experiment, you can't control for lurking variables. That's the ice cream example. Yep, because ice cream is connected to shark attacks, but the lurking variable is summer. You got it. Great job, everybody. Yep, very, very important concept in statistics. There could be outside variables because we can't say studying causes people to pass the test. It could be that people who go to class are more likely to study, and thus it's not studying, it's going to class, because there might be other variables. You could do an experiment, though, which we don't talk about. I like ice cream, too. But no, lurking variable is very important. We'll do a final more bit here on chi-squared, then we're going to switch topics. Let's do a calculation of expected counts and a calculation of chi-squared. This really comes down to formulas right here. I'm going to try to remove these. So you might be presented with a table like this. And when you do it, let's put the review 3 in the chat. Practice your formula sheet. We're going to switch topics here after this. I want the expected count for... See how quickly you can get this. This is your practice. If we wanted the expected count for this cell right here, what would be the formula? So take a moment right here, see if you can solve it. What is the expected count for that? Now, the formula for expected, I'll write it on here. It's on the review sheet. Thank you so much, Ditto. That's row total times column total over grand total. Rather than look at the formula sheet. That's a great job. Yep. Row total times column total over grand total. And so you want to pinpoint in on it, and you can write the equation on it. So what is going to be the mathematics? I think Casey's got it. Great job, Casey. Amazing work today. And everybody, great work. Casey circled the row total. the column total. I begged people when we did written tests to do this. Sometimes one time I printed up like 100 tests for my students, brought them to class, and had everyone doing these steps to be like, because you have to create that muscle memory. So try writing these things down, try doing it yourself, because it's just doing a process, getting a step-by-step procedure saying, if I'm doing expected, I circle the row, I circle the column, I multiply those two, I divide by the grand total. And people are showing the mathematics right there. It looks like it's 123.9. And we can confirm. There it is right there. Great job, another 100 points. So that is how we get an expected count. And that's what we would expect by random chance. It actually works off the rules of independence multiplying probabilities. So I won't go into the specifics on it, but theory on that is the rule of independence multiplying two probabilities. So now we want to get all the cell chi-squareds. Now you'd have to get all of these if you're doing it by hand. We don't work all this stuff by hand when we do statistics. We let the computer do the work. But we have to know the theory behind it. If I want to get the expected or the cell chi-squared for this one, what is the cell chi-squared? Now the cell chi-squared is the very famous formula made popular by Mendel and his pea plants of observed minus expected squared over expected. Now people look over here and they say, I don't see observed. People say, what? Where's the observed? Oh, I didn't put over expected. I was like, that formula doesn't look right. That's a cell chi-squared. I love the chi-squared chapter. I think it's one of those ones that's a little bit easier. There's no confidence rolls. Great job, Zaid. Right? And Kayla's right. Another 100 points in the chat. You are correct. The observed is just the count because that's how many you count in that group. So go ahead and take a moment. Not equals. So take a moment, try to solve it. Remember, this is your time to practice. When you get to the exam and it says calculate a cell chi-squared, you're like, psh, observe minus expected squared over expected. Easy question. It's easy if you know it. Everything's easy if you know it. 5.0, that sounds right. I'll put the numbers in. I'm going to trust Kayla's mathematics. So, try solving it in your calculator too. The more you do these things, the more muscle memory you make of solving them, and you learn how to write numbers. I'm still learning. I was like, that doesn't look the same. But it's all about that practice. It's all about the more you solve problems, the more you get to the test, you're like, oh, another expected cell count? Another chi-squared? So, I trust your mathematics. Watch this. You ready? Boom, right there to the decimal when we round it. Kayla, 100% trusts you. So we got this right here. Great answer, 5.02. Does anyone have a guess? I just want you to do a rounding. I'm going to take a guess too, and I'm going to throw 500 points if you beat my guess. Who knows what the chi-squared test statistic will be for this? I'll give you literally 10 seconds to do this. I wish I had a 10-second timer. Take a guess. I'm going to try to figure it out too. Figure out the chi-squared test statistic. Okay. I've got a guess. Can anyone beat my guess? I got a number in my head. I think the chi-squared test statistic is going to be. Can anyone beat my guess? 500 points if you can beat my guess. I'll take the first guess. Throw 100 points if you don't beat it. I don't think it's 52. I don't think it's 52. Maybe you're right. Maybe I misadded. My guess is 26. Let's see how close we are. Very close to 26. So the chi-squared test, this number is found how? How did I take a guess? I'm gonna throw 500 points. I don't care. We're just going crazy today. I like guesses. And so what did Brian do to guess 26? How did I come up with this number in my head, which is an important thing we need to know how it's found? What was I trying to do? And I was doing it in the background, and I guessed about 26. So it's pretty close. What did I do to get this number? And say you see it, Kayla, right? I'll show it here visually. We need to re-screenshot. So that number of 26 down there is found how? Oh, not that, not 5 by 5. How do we get that Pearson? How is that number down there, that 25.736 found? How is that 25.736 found? Great job, Casey, right there. Adding all these right here. I was adding all these in my head. I was rounding them and kind of adding decimals across, and those add up to 26. Does that make sense? So the Pearson chi-squared test statistic is the sum of all the cell chi-squareds. Does that make sense? all those numbers right there summed up. Like if you do the summation of all the cell chi-squareds, and do go to the formula sheet because it does mention this. So if you print off, highly suggest printing off the formula sheet. Go to the formula sheet, and it says down here, the sum of all the cell chi-squareds. That's what that stands for over here, is when it says the chi-squared test statistic is the sum, and these are cell chi-squareds. So the way we get this chi-squared test statistic, which is this value right here, that's the chi-squared test statistic. About 5, a little over. Oh, yeah. Great job, Kayla. 100 points right there. Yep. And yeah. So good stuff right there. And yeah. I think that does it. That's pretty much all the concepts on chi-squared. That was a mini 40-minute lecture on chi-squareds. I think, Casey, did you have questions about one proportion? Let's head to the main screen and do more questions. We'll do another topic or two. Might go for about 2 hours today. If you're 320 or something, drop a question. We could do some 320 or 474, 475, 522. So many questions. Let's over to the main screen. Our new music. What questions do we have? Where shall we go right now? And thank you everyone for being here, for practicing. Check out the review videos on the review page. Lots of great review. We should probably interpret some confidence intervals. I'm out of coffee. And I need to put out I've got the form, don't I? Let me drop that in here. I need to put up like a stream where people can just check their numbers. And I might just like do that. Might stream like the stat to one thing. Watch YouTube get mad. Can you do interpretations for the true proportion, the true mean, the true difference? Yeah. So I think this kind of Casey and Zaid's question right there kind of overlap. Interpreting intervals. Let's do some interpreting intervals. Let's go check it out. Interpreting intervals on Stat 201. Let's go check it out. I love this song. Yeah. So Zaid is doing a 2-sample T right there. Let's do that. That's probably one of the toughest ones to interpret. So when we are doing, I swear, what is going on? When we are doing a confidence interval right here, just trying to think, my brain's broken. Let's wait, I'll change it off of this. Let's go to honors program and let's go to high school GPA. Cool. Okay. When we do the 2-sample T, we need what variables? When we do the 2-sample T, we need what kind of variables? Good review right here. Remember, just as many questions as we can talk about. 2-sample T requires what variables? This is a 2-sample T, so you can kind of look at the screen for hints right now. We need a categorical X and a quantitative Y, exactly. So we need to break apart a quantitative variables into 2 groups. Just think 2-sample T means we're doing the means for 2 groups. We're comparing the means between 2 groups. Now, what would the null hypothesis be for the difference between the mean of the yes group and the mean of the no group? Insert. What would the null hypothesis be for the mean of the yes group? See, ditto. What would the null hypothesis be? What would the null hypothesis be? I'll run the test while I ask you that. There's no difference, exactly. So the null hypothesis is basically that the true mean of somebody's GPA who's in the honors program, their high school GPA, is equal to, and you could say equal to, that there is. Great job, Casey, right there, writing it out. Casey, 500 points. Amazing practice. Casey has it written out in the chat right now. You can also mathematically solve that mu1 equals mu2 if you bring mu2 over to the other side. So the null hypothesis would be that there is no difference between the 2 groups. Now, this is where we have to know how to read this output. I'm going to try to make it a little bit smaller and then zoom in on it. Let's try that right here. Okay. So when you look at this output right here, probably the most important thing for us is going to be if the difference is positive or negative. Now, when the difference is either positive or negative, there we go, nice and neat. When the difference is positive, that would be evidence that the what mean is higher. This difference here is positive, so that is evidence the what mean is higher. Now, I know I want to hear kind of a little this or this. The difference is positive, and the yes is the first one, correct. And Jump will put yes first, and the first one, yep. Because if you were to do something like 10 minus 8, you'd get a positive number. But if you did 8 minus 10, we're just talking theoretical numbers, 8 minus 10 would give a negative number. So the difference is negative. That would be evidence the second mean is higher. And this difference right here is what we saw, 5-letter word. It's the group we collected on. This is the difference we saw in the what. This difference right here is the difference we saw in the what. This difference right here is the difference we saw in the what. It's a 5-letter word for the things we collected on. We have so many observations. This is the difference we saw in the means, but the what means. The sample. Does that make sense? And the null, we could easily write it right here, is that the mean for yes, and this is a cool thing you can do with this output too, is you could just write here that mu1 equals, or I used to do it this way too, mu1 minus mu2 equals 0. There is no difference. Does that make sense there, Reese? The null would be that the difference is equal to 0, and that means there is no difference. Like, if I tell you my brother and I's difference in basketball points is 0, that means there is no difference. So the null is that there is no difference, but we observed a difference of 0.311 in GPAs between the yes group and the no group in our sample. Great job, Reese. Thank you, Reese. 100 points right there. Now, let's not worry about statistical significance here for a moment. Who would like 0.3 points on their, who would like 0.3 on their GPA right now? Like maybe you're at a 3.5 and I give you, I say, well, now you're at a 3.8. Just I snap my fingers. You snap your fingers. Oh, that was, oh, wait. Okay, now we're back. But you snap your fingers and you go from a 3.5 to a 3.8. Sam's like, make this happen right now, Brian. Sounds like a pretty big difference. And the pretty big difference sounds to be what by random chance, given there is no difference here. Sounds, and we don't do things in statistics by sounds because the p-value is going to tell us if it's likely by random chance. But just by the 0.3 itself, which sounds like a pretty big difference. Sometimes it's big enough that we're like, yeah, that's a pretty big difference right there. So this difference we observe of 0.3 of a point between the two groups is very what? This difference we observe, well, reverse it, Zaid. I think, well, I might have said right? So the difference we observe is very unlikely by random chance, right? Because low p-value, right? Likely would be high p-value, and then unlikely or not likely would be very low p-value. So you're like, unlikely. Because remember, if I tell you, think about it this way, there's a 90% chance it rains today. It is what it'll rain today. So just pretend for a moment the p-value says something like this. There's a 90% chance it'll rain today. It is very what it'll rain today. Just think of p-values like that. They're probabilities. There's a 90% chance it'll rain today. It is very likely it'll rain today. Now change it to the current example. There is a 0.00001 chance it'll rain today. It is very what it'll rain today. So now there's a 0.00001 chance it'll rain today. It is very what it'll rain today. So when you think about when you look at it that way, so now it's very unlikely. Does that make sense? You'd say, and the p-value tells us how likely these things are by random chance. You can think of random chance just by like, it's going to rain today. And so exactly, the closer to 1, the more likely it is. The closer to 0, the less likely it is that what we saw was due to random chance. So it's just telling you a probability that what you saw is due to random chance. Hopefully, did anyone else have maybe an moment? This is just telling us how likely it was that it is due to this. P-values are a weird thing, and I think a lot of people don't understand them fully, which is totally all right. I'll tell you the truth. I probably didn't understand them fully for the first year or two I taught the class. And then all of a sudden you teach it more and more. It goes off the assumption that the null is true, and it's saying, if the null is true, how likely was this thing that we saw? So, yeah, given that the null is true, what we're seeing here is very what? Just use one word. Given the null is true, this difference is super what? Like the null, let's say the null is true. Let's just assume the null is true. If we assume the null is true, that difference we observe is very, very what? If the null is true, that observed difference is super this. You're like, if the null is true, then that is a very what difference to observe. If there is no difference, if the null is true, then that difference we observe is very, very what? Go back to the original word I'm looking for. Unlikely. You got it, Trevor. That difference is very unlikely. Because remember, low p-value, very unlikely. Great job, Demetrius, right there. So what are you going to do? So you're saying if the null is true, what we saw here is very unlikely. So if you state your conclusion right here, what would you say? Let's take a moment right here. I want you to practice stating your conclusion again on this test. So this is another state your conclusion thing, and then we'll do the confidence roll next. But write your conclusion in the chat. We'll throw out some more big points. So take a moment. I'm going to use the context here in a moment. So we're going to erase the previous things, and we're doing some 2 sample T right now. Here's what you need to do. So I can probably grab the full thing. Oh, we have it as a picture right now, don't we? So who has the conclusion? Try writing it out. Remember, this is good practice. And then we'll talk about the interval next. Just take a moment. It's the practice that makes perfect. All these trite sayings. If you thank you everyone who's joined the Discord. You can see I've got 9+ messages. We've had so much interaction lately, and I'm really going to try to stress it at the start of next semester, because I think we're really showing at the end of the semester how valuable it is. A lot of people asking questions, getting questions answered, all this great stuff right here. I'll answer a question in about 30 seconds. Someone's fast forwarding right now. In the future, not currently. Can't fast forward while you're watching it now. So we'll probably, unless otherwise stated, usually we use the does not equals alternative. So usually, unless the problem states, see if that people with the honors program have higher GPAs, which would be the second alternative. We usually go for the does not equals alternative, like unless the problem states. So yeah, if the problem says test to see if yes has a higher GPA, it would be the second alternative. Wait for the song to end. Okay, people might be typing it. Let's try this. So here's the interpretation. My p-value, do you want, we're just doing p-value right now, then we'll do confidence interval next. Great question, Zaid, right there. My p-value, what is the quick key for that? Control L, that makes sense. And then control right is that, yeah, okay. My p-value, 0.0, I think Casey does a great job, yeah. Of less than, I don't think that'd be that big of a deal, is below alpha of 0.05. There's the first part we mentioned at the top, and I'll zoom out so you can see a second here, or I'll just disappear. Thus, we reject the null hypothesis that the true difference between high school GPAs of honors versus non-honors is 0. We have evidence that the true difference in GPAs is not 0. Let's see here. So if you feel like 0.01 is below my alpha 0.05, reject knowledge, there's no difference in the means of high school GPA. Yep. And I might add true. There's evidence that the difference between, and I might just add true. Yeah, Casey, 500 points again. The only suggestion I would make, and if my graders took off points on that, I'd say, no, that's about as perfect as it gets. The only suggestion I would have is like true or population to add in there, because we saw a sample difference. So Casey, great job and great practice right there. I would just add in true. This is my only suggestion. And if I saw that and my graders took off points on your answer, I'd be like, that's a great answer. Like, that's great. We just want to make it perfect. So that's what we're here to do, is like make everything perfect. You might even have a suggestion. Maybe we've got a statistician watching right now who says, you know, Brian, you should improve this. I'm always trying to improve my knowledge too. So now we go to the confidence interval. And so what is the confidence interval going to try to estimate? This is an important thing, which you can see right here. Take a moment and just think, what is this confidence interval trying to estimate? Yeah, Zaid. I think Zaid's going to finish. Zaid, great job right there. What are we trying to estimate? Zaid and other people have written out. Yes, perfect, Zaid. And so what are we trying to estimate? Zaid has mentioned it. So what are we trying to estimate? So when we do confidence intervals right here, and we can kind of go to a new sheet. So look at their answers that are currently on the screen. We're just going to go to Google. Sure, why not? So, so when we go to confidence intervals, okay. So 1, state your confidence level. State what you are estimating. 3, give your interval. And then let's go here. What is the middle one? I'm trying to memorize these. E. Give context. You have to give the context. So when we do this right here, what are we trying to estimate? Well, we were just talking about it. Yeah, exactly. The true difference, right? So we are trying to estimate the true difference. So when you look at this interval right here, I am 95% confident that the true difference between the high school GPAs of honors versus non-honors honors students is contained in the interval, and we could say between high school students, true difference between the high school students of non-honors minus the true difference between the high school honor students minus the non-high students in the interval 0.3833 to 0.2387. I might add an additional sentence on this, and I'll explain why. Let me do some color coding right here. There's the give the interval part of it. State your confidence level. Just go through these steps right here. The hardest part for people is what? Which of these 3 steps do you think people usually have the biggest mistakes on when interpreting confidence intervals? Where do you think the mistakes are usually at? And then, I did let me change it to lower upper. I wouldn't take off points if a student did this. I do agree. Let me throw 100 points. I do agree we should probably go low, like the lower upper. I did upper lower. I wouldn't take off points if a student did that, though. I'd be like, whatever. Still just an interval of numbers. And so to part 2, Mohammed, you're right. The second part is usually like, one, stating the interval is pretty easy. Giving your confidence level is pretty easy. You just look to like what confidence was used right here. So that's the confidence level used. Usually the errors occur on part 2. What are we talking about? What word will pretty much always be in when we are talking, like what word is consistent in our interpretations with whatever we're estimating? What word, 4-letter word that we can't handle? What word? It's an old joke. And this one's not a percent, correct? Because this is the true difference between means. Some of them are percents. Depends on what we're estimating. What word is always true? Yep. So this word right here, true. Let me find a better screenshot. So, estimated mean will be for quantitative variables. Just depends on what we're doing, but we're always trying to estimate the truth. Does that make sense? We have a sample. So we go out and take a sample, and then the sample is a view into the truth. That's what confidence intervals do. So true is always going to be, can you go over and explain? We could do some of that, Reese, here. We'll do more interpretations, then Reese, we could swing back around to that. We're always going to have this true. Does that make sense why we're always going to have this true? Thank you, Reese, so much. 100 points, Reese. We're always going to have this true right here. And so whenever you're interpreting, you want to make sure you're talking about the true this or the true that. So if I switch questions and I go over here and I do something a little bit crazy, which Jump can do so quickly for us. Let's go over here and let's say this right here. And let's run this. Okay. Just interpret, take a moment, see if you can write out a proper interpretation for one of these confidence intervals on the screen. Take a moment, see if you can do it. Interpretation slightly changes. I'm going to screenshot it while we're doing this and maybe change the way this looks to get a nice, pretty screenshot on here. So there it is right there. Let's bring it over to our page where we're doing the interpretations now. Be thinking about how you're going to interpret it. The context is going to change right here, but other parts are not going to change. Yeah, Kayla, that's exactly it. That's how we use statistics. Kayla, 100 points. Kayla said, you want to understand the truth. The sample just gives you an estimate. It gives you a guess, like a good idea of what the truth might be. It's a guess. It's a starting point. Like say, well, I saw this, so the truth is maybe near it. And the truth, we give a margin of error on it. So a lot of output on the screen. Not a perfectly written test question, but kind of going off of this, how would you interpret one of these intervals right here? This is where we want to get you to with your knowledge, especially with interpreting. You might see output like this. You're like, oh, we're trying to estimate the what. Be careful. You have to think, what kind of question are we asking? This question is categorical based. It's what is your political ideology when it comes to social issues? So take a moment, try to practice writing it out, see how close you get, and if I would say that's a great answer. Now, don't worry if you get it wrong, don't worry. We're just here to practice. So what would you write for this when it comes to interpretation? So this is kind of the basics right here. This is a structure. I'm 95%. Yes! Demetrius, 500 points. I'm just going crazy on those points today. Thank you everyone here reviewing. Demetrius, perfect answer right there. I'm 95% confident that the true proportion of very liberal, and we could say students, it's the only thing I might add, is contained in the interval 0.036, blah, 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 to 0.66873. That is just amazing right there. That's exactly what I'd want to see. I just might add students on there. But no, like that's the only change I would make. I see that and I'm like, yep. I would just be like 4 out of 4, done. Like I'm probably not even going to think. Like I'm 95% confident the true proportion of liberal students, I might add, is contained in the interval blah, 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 blah. As long as you're using the right intervals, that's great. I'm 95% of the true proportion of moderate people and people, like I didn't give you context, don't worry, that's my fault right there, is contained in the interval 0.361 to 0.428. Yeah, exactly. Oh, you did the liberal? Mm-hmm. Is this making sense right here? If you're seeing the answers in the chat, people are doing a great job. The change right here is we're talking about the true proportion. So the context is proportion. Now, someone's wondering, why is it proportion? Someone's probably saying, wait, why is it proportion this time? Why did we switch this up here from true difference between the means to true proportion? Why? What's going on? Explain that in the chat for me. What is going on? Why? It's probabilities, it's categorical. And with the previous one was decimals off also, but it's GPA. GPA is not proportion of GPA, and true proportion is for categorical, exactly. The question itself, always go to the question we ask. Like when you go up and ask someone their GPA, that's a quantitative question. So you'd see the average GPA for this group, the average GPA for this group. So you're comparing the difference between the two groups. When you go up and ask somebody, you know, are you liberal, conservative, moderate? You're asking a categorical question, and then you'd have proportions of people in a category. Like if I say 40% or 30%, that's in the interval. 30% of UT is conservative. That would make sense. You'd be like, okay. If I tell you the mean conservative of I'm trying to make up something that doesn't work, but we're just trying to do a category right here of like what percent of people are in the category. Proportions are percentages. They're kind of synonymous. If you times them by 100, you get a percent. The last one was true difference because category, exactly. But we do have other usages of quantitative too, because here we'll go back in time. Back.
Why is this kind of...
Back.
Tiny Brian.
Okay, good. Everything's fine. We do have another interval. And the other interval is known as a what interval? Tell me what kind of interval I am making right here by running an analysis like this. It's not the end of the world if you don't know the name of this interval, but it probably helps. We're just doing classic 95% confidence rolls. What kind of interval am I making right now by looking at this interval right here? Knowing it's very important, I'd say. So what kind of interval am I making right here? Just thoughts on this interval, and let's try to interpret it here in a second. Take a moment, putting on some chill music. So what kind of interval am I making, and can you interpret the interval? Zoom in a little bit here. Should be big enough to see, I think. That is correct, Saeed. So what do we call it? It's not the interval if you don't know what we call it. One sample t interval. Well, it'll be connected to the one sample t test, but yeah, it's a one sample t. Or known as sometimes people just call it a t test or t interval. But if it's one sample because we only have one group right here. We're not splitting this apart into like the previous example where we did honors versus non-honors was a 2 sample because there's 2 groups we're comparing. The 1 sample T just says everybody in one group. There's just one quantitative variable being analyzed here. Hence a histogram, one quantitative variable. So what do we have right here? You got the interval right there to talk about. So try filling in the context of this right here. Just kind of got a good structure down here on the bottom. Try taking a moment, especially if you're watching in the future, to write this down on your sheet of paper or type it in the chat. I am 95% confident. Oh, you might have saw a 2 right there, Kayla. That's a 3. Don't worry. I am 95% confident that the true mean of a student's high school GPA. But one thing real quick. The A student I might remove. Taylor, I'd probably write that. That might be 3 out of 4 for 2 reasons. There's a small typo on the 2, maybe because I've got a little bit small. That should be 3.78. This is not for a student, it's for all students. There's a good Pearson question that does that with like the difference between traditional versus non-traditional. Not that a student would have this difference, but the true mean difference for students. But we're talking about the true mean high school GPA of all students. So let me throw some 500 points. Trevor and Kayla and everyone right there are taking some great practice at this question. So I'll write the interpretation and put it, yeah, I know, right? Because it does like the difference for a student or for these students. So that's the only grammatical thing. I'd some of these interpretations I read them, I'm like, no. I read them like, no. Someone's like, we say interpret the interval. Maybe I'll write down some of the bad stuff I've seen. I have 95% of the true mean GPA of the true mean high school GPA for students is contained in the interval, and then we just give the upper and the lower. So why is it true mean? Because we are just analyzing what right now? It's true mean. Someone's probably wondering, why is this true mean and not proportion anymore? Why is this true mean and not proportion? Who can help us explain to someone who's watching and saying, but why did you go with true mean this time? Why is it, it's quantitative, yep. Because when you ask a question like, what is the GPA of students, you would take the mean of it, not the proportion. So you always want to think, what am I talking about? You're always going to say true to this. You're going to say the true, like what is the actual GPA of all students, the actual high school GPA. And so that's why I want to say for students, like exactly right here. So it's for like all students, it's one quantitative variable. So really good practice right here on interpreting all of them. And if you can't tell, I'm having you write these interpretations to practice them because maybe there's written questions. I'm going to say to graders, please make it a priority to grade as fast as you can. Not as fast. Don't grade fast. We want good grading. Grade fast and grade accurately. Goals that work in conflict with each other sometimes. I do want them to grade accurately and I do want them to grade quickly. Woo! Easy and fun stuff. I like it right there. And then I think there was a question about... What was the question? There was a question. Zaid, did you ask it? We'll go back. We might go to the main screen. This was a good thing on conference roles. We basically covered all the conference roles right here. Let's go back to the main screen. Remind me of those questions that you want right now. I'll probably go for 2 hours today. I think that'd be good. Might come back later tonight. You never know. Never know where we're going to appear. Using the formula? Oh, like which formulas to use? Oh, yeah, I think Reese was asking about using the formulas, right? So... let's do a formula question. Can we do true false? Yeah, we'll do true false. Yeah. Here we'll do a little bit about the formulas right here. And let me think right here. What's the best way to teach that? I asked if you could use the formula to solve for the interval. So let's go take a look at those formulas again. And let's just talk about the output right here. So let's talk a little bit about output and notation. So there's output and notation right here. And then we'll do some true false. You're welcome, Zaid. Anytime. Thank you so much, everyone asking all these questions. People come back, use these videos. Great practice. Let's go check it out. So here I'm going to highlight stuff. Just tell me yellow is this is this, or I'll put numbers beside stuff. That's going to be easier. I want you to tell me in notation, what are these things? I mean, some of them just say what they are. Probably important to know what all these things are right here. Just going over this output. Just knowing what you're seeing is very important. So what are all these different things? Just try to identify some of them. Take a moment. Y bar. Exactly. That's the sample mean. Exactly. So Y bar tells us it's the sample mean. So if you see something like sample mean, that's Y bar. The standard deviation, that's sample standard deviation right there. So that comes from a sample. Not the 5-number summary yet. So the 5-number summary would be the min Q1, median Q3, and max. And so what's interesting, Demetrius, great question right there. So mu is what we're trying to estimate. Mu is true mean. So mu is what we're trying to say might be in this interval. This is an interval to estimate mu. So mu is not in the output, but the interval is trying... Does that make sense, Demetrius, right there? Like, mu's not in this output because we don't know what the truth is, but that interval right there, which we could just say like confidence interval for this, the confidence interval is being made to estimate the true mean. So we we think we're 95% confident the true mean is contained in that interval. We don't know what the true mean is because we don't have all the data. So it's a really great question right there. Like, so mu is the truth. We don't know that. We are using an estimate, which is y bar. And so we got that right there. Excellent question. And then I think Catherine is going for the tough ones right there. The SEY bar. Exactly. Yeah, Catherine, that's the one people usually forget right here is the SEY bar. And so what else do we have? The last thing on here, I think people know it. It's on the screen. Last thing right here, it does it as a capital this, but we don't do it that way. Jump, what you doing? What are you doing here, Jump? Why do you put it this way? I don't know why. The last thing on the screen is what? So that the thing we just marked, number 3, was the standard error, the sample size n, exactly how many observations were taken. Now, here's the thing. I can tell you very quickly the margin of error for this interval. The margin of error for this interval, the margin of error for this interval, I can estimate, and I am estimating it to be, I'm trying to do it very closely in my head. You probably get a calculator to do it faster. Who can get the margin of error for this interval? Let's circle it. Circle it in red right here. I'll go green. Who can get the margin of error for this interval? I want you to tell me the margin of error. I'm going to estimate it pretty quickly right here. I say it's 0.027. 0.027. 0.027. My estimate is that. Is it that, Zaid? I am correct. 0.027. How did I get that? Now, what is a way you could get the margin of error? Nice job right there, Demetrius. You guys, well, Demetrius and Kayla, well, we're just going crazy with those 500. I think Demetrius is exactly correct, more exact than I am. So how are people getting that? And I actually solved it a bit of a different way. So my estimate was point. Yeah, that's pretty close, right? Zaid, great job on that. Good guess right there. Good guess, Zaid, on that. Good guess. That's a good guess. So probably the best way to get the margin of error is to know it's what. We'll draw it out here visually because we want to make sure everyone sees what we're doing. The margin of error, if you go like this, and I always like to do simple questions for this. If I tell you a steak dinner, we're going to go to a really nice restaurant, is going to cost between $40 to $50. Don't worry, I'm paying. This is a stat to one treat right here. What is your estimate of how much the steak dinner will cost? I just want you to give me an estimate of how much the steak dinner will cost. I tell you it's going to be between $40 to $50. I want your estimate of how much it'll cost. So I say, about $40 to $50 for the steak dinner. I want an estimate of how much it'll cost. You say, well, it'd probably be about this. You'd be like, probably about this, 45. Now, when you write stuff as an interval, you always write 45 plus or minus, and that kind of gives you the hint for the answer for the margin of error on this interval. So the margin of error, I think Demetrius has it right there, is going to be 5. Great job, Demetrius. The margin of error is 5, and then I want you to tell me conceptually the margin of error is always what the interval. Conceptually, the margin of error is always what the length of the interval. So here we'll do it in different colors to help out. The margin of error is always what the length of the interval. The margin of error is always what the length of the interval, because it's a plus or minus. It's always half the length of the interval. So we can see the margin of error is 5 for this interval, because I'm like, $40 to $50. Sometimes people forget to do it. So when you think about this, what's the first thing you would want to find if you're going to find the margin of error? You would want to find the what to find this. And we'll put our numbers in here in a moment. You would want to find the what if you're going to do this. And just think, you were doing this in your head like this. Like you do it so quick in your head, you don't even realize you're doing the mathematics. You would want to find the what. And I'll write the equation for it. So you'd want to find the what right now. The length of the interval. How long is this interval? How long is the interval? So the length of the interval is actually 50 minus 40. So it's 10. 50 minus 40 is 10. And we do that without even thinking. And then you would want to do what to that length of the interval. So you'd want to do what to the length of the interval once you get the 10. And then you just divide by 2 to get the margin of error because it's half the length of the interval. And that's how we are getting 5. Like there is the mathematics right there. So we can do the same sort of process with our interval, but it just has decimals. It's not as pretty as numbers. So our interval, and I'll show you how I solved it even quicker because I used a trick. Our interval has an upper of 3.835, and you can carry all the decimals as far as you want. The test will say how many decimals to carry. If I'm doing the test, I'd probably carry all my decimals. If I'm showing an example, I'm going to make it look nicer. So now what are you going to do to these two numbers? So I know, right? It's once you realize what you're doing, you're like, okay, so let me just do that on this problem here, because now we're going to do what? We're going to do what right here? Yep, great job right there. Yep. And so we do that, and we get 0.027. Demetrius wrote all the decimals for us. So we're just taking half the length of the interval. Like how far are these numbers apart? What is half that distance? Now, I did a trick. I don't suggest doing this because it only works in this instance for two reasons. If you do z-scores, which this is not, what is the z-score for a 95% confidence interval? What is the z-score for a 68? What is the z-score for a 95% confidence interval? What is the z-score for a 95% confidence interval? What is the z-score for a 95% confidence interval? 1.96. Muhammad knows exactly. 1.96. Now, what are the degrees of freedom for this t? Because we could take this right here and add in another notation and do degrees of freedom and write this. The degrees of freedom are this for this one sample t, because the degrees of freedom are what? So that says 805. And great job. Good to see you here. Hailing, everybody. So the degrees of freedom are what for this? Like, tell me mathematically. I'm writing 805, which are the degrees of freedom. It's 805 and why? Like, exactly. This is a one sample t, so the degrees of freedom are found mathematically by what? N minus 1. Now, here's the thing. When you do, and once again, you wouldn't have to, this is the advanced way. Like, this is the, if you know this way, you're doing something well beyond. So, yep, 805 exactly. So here's the thing. Remember how we just said the z-score is 1.96 for a 95% confidence interval, and we'll just show it the way it should look for 95% confidence. So the z-score is... I don't think it's showing. There we go. 1.96. But if we have 805 degrees of freedom, then the t-curve at this point, and this is just in this instance, is what? The t-curve at this point is basically what? And take a look. The t-curve is basically what? Because the t-curve converges towards this. The t-curve is mostly different at smaller degrees of freedom, but with a large amount of degrees of freedom, it's basically this, for all intents and purposes. And that's what I was doing in my head. It's basically normal. The t-curve becomes the normal as it has more freedom. With very little freedom, the t is not normal. The t is basically a more exact calculation. William Gossett was like, the mathematics are off. I'm going to do a more fine calculation. Like, this is the real deal statistics. William Gossett improved upon the normal curve. So the normal curve always has one shape to it. Rock? It doesn't matter. It's going to look the same no matter what, but the t-curve is based on degrees of freedom, and the more freedom the t-curve has, the more normal it becomes. T with very little degrees of freedom, not very normal. T with more degrees of freedom, super duper normal. So all I did when we had this output, since I knew we were making a 95% confidence interval, I went and took this number right here and rounded point this right here to the following, and then I did what? So I just took that number right there of 0.01413 and I rounded it to 0.014 and I did what to it? What do you think I did to it since I'm saying, well, I'm building a 95% confidence interval? Since I'm building a 95% confidence interval, I said, well, let me just do this to it then. And if you get this, this is the advanced solve. I said, once again, I wouldn't do this on a test. I'd take half the march. I'd take half the length of the interval. But if I'm just estimating, I'd say, well, then just let me do this to it. Because it's a 95% confidence interval. So let me take the standard error. I'll write the formula so you can see it. So the formula is... I'm going to go to new question very soon because this is advanced. Y bar plus or minus T S E Y bar. So I know this right here is equal to about this. So what did I do to make my 95% confidence interval in my head? How did I come up with 0.027? Look at what it's very close to. This is how I was solving it in my head. So what did I do? Because we're interested in this margin of error right here. So what did I substitute in for t to solve it in my head? So how did Brian solve it in his head? I want people to kind of see how I'm able to solve these things. What do you think I put in for t? Like, what do you think Brian used for t when he solved it in his head? Well, so what do you think I put in for t? Because I'm basically doing a 95% confidence interval. We'll just think it's a 95%. Muhammad right there, 100 points. Great job. 2. And, well, the thing is think about this. Since I'm using 2, which is not the exact, I've rounded both these numbers up. So what does this solve to? This solves to this. So since I rounded both numbers up, I then said, well, maybe I should go down a little bit and maybe the answer is closer to this. Does that theoretically make sense that I was like, let me round this number up to make it 0.014 to make it easier to multiply? Let me round this number up to 2 to make it easier to multiply. Well, the answer is 0.028. Well, I rounded both of them up. Let me just take a little bit of that change off of those. And it's probably about 0.027. That's how I was able to make a good guesstimate of it. That's what my brain is doing in the background, being like, well, it's basically 2. Well, it's basically 0.014. Let me multiply those. Well, I rounded them up, so let me round this down a little bit or just take off a little bit. So that's kind of how, if you know the concepts, it makes sense. Like I'm building a 95% confidence interval, and we saw these concepts. A little bit advanced right there. We're going to switch topics. Hopefully, I saw an O moment right there, which we like. But here, let's go to a new concept. Yeah, just take half the length of the interval. What you want to be more decimal accurate, like, but if you do that in your head and you're like, it should be about this, that'll give you a good guesstimate of what it's at. If you have enough degrees of freedom, the t is basically 2 at most points for 95% confidence. Depends. If it only works for 95. If you're doing a 98, it'll be a bigger t. I will not be doing that reset. 100 points. I thought there was another question people had. What was that next question people had? I saw another question about, can you do this? Can you explain this? Drop that other question. Oh, true false, right? I think true false is next. Let's do some true false right here. Can people throw me ideas for true false? I want to do true false, but I'm just like, we'll put some type 1, type 2 error in there. Like, throw me ideas as I write my true false. I'm gonna try to write 10 true falses. Let's go check it out here. Okay, let's test our true false knowledge. People are afraid of true false. People's like, don't put true false questions. I got a 50-50 chance, but don't you dare put some true false on that test. The whole test will be true false. It's funny, like, I feel like, would you rather take a whole multiple choice test? Let me poll the audience on this. Would you prefer a whole test that is multiple choice or a whole test that is true false? Whole test. Which of these would you prefer? Then we can do some tools and techniques next, yeah. Okay. All of these are true false. Here, we'll highlight the answer when we get it. Okay. Just gonna yawn a lot. Excellent stream. Okay. Okay, go copy that. That'll work good. No. Okay. Multiple choice. Really, that's so crazy. It's 50-50 right now. It's like a true false. But random chance, you're more likely to get a true false right. I find it so interesting. It's such an interesting. True false is winning out now. Cool. Good review of that topic. Depends on the questions. Throw some chapters you might want to review over here. almost got a full page of stuff. Make it a little bit smaller. Sure. Wow, that's perfect. Okay. And can't think of wow. We have 1, 2, 3, 4, 5, 6, 7. So we need 3 more. Okay. Oh, cool. I don't know. Sometimes I don't know. I try to like think of concepts we can cover right here. So kind of a review of certain concepts right here. I think someone's cooking some lunch. Smells good. So when there is a large effect size, the test will be more powerful. So you might be wondering, what is effect size? That's kind of the big concept to think about right here. Like, what is effect size? Effect size is the difference between the null and the truth. So we need to think about what effect size is and what power is. Oh, you might be right, Kaylee. You might be right. So the people are saying true for the first one. So when you think about effect size, I'll put some notes in here. Effect size. Oh my gosh. So a lot of classic examples here of what a larger effect size is. So this one is very true. Effect size, you can only really estimate the effect size. Yeah, big difference. Like, we have a lot of examples, like when Brian plays LeBron James in basketball, you would assume that there is no difference between LeBron and Brian. Exactly, the MJ example versus Michael Jordan. Or we do like when someone is sick. If you assume someone is healthy and they're just like, like you might see me like just like sniffle or something like that, like, oh, is Brian sick? But if you know, when there was a large effect size earlier in the semester, concept about that, then it's easier to reject the null and be like, Brian's not doing so well. So, you know, I'm not sick right now. But what we have right here is Zaid and Muhammad, remembering the examples. So when you compare my brother and I, let's say the null is false. Like Brian's basketball skills versus his brother's, look at that applies. We don't care about grammar here. Basketball skills. So when you compare Brian and his brother, what would you assume about Brian and his brother? You would assume what is the null hypothesis here? So you got Brian playing basketball and his brother playing basketball. We're going to play some games. What would be the null for like how good Brian is and how good Darren is, who's my brother? And the null hypothesis should probably be that we're what in our basketball skills, because you don't know what's going on. Yeah, you're like, it's Brian and his brother. There is no difference, right? That we're the equal. And so if Darren is way better than me, it's going to be what to see that. Just put like a 4-letter word meaning, oh, of course. If Darren is way better than me, and Muhammad's kind of going to the point, which, yeah, that we really can't see, then if Darren is way better than me, it's going to be what to see this, to like and reject the null. Just think, if Darren which he is way better than me. If Darren is way better than me, which is a large effect size, like this is the truth. You're saying you assume there is no difference, but let's say the truth is Darren is just way better. Then it's going to be what to see this. It's going to be way easier, right? Does that make sense? Easier, exactly. It's going to be way easier to see this. And when the test can reject the null more easy, we say it's more powerful. The ability of the test to reject the false null, because the null is false. Than his power. Well, the test would be powerful then, because if Darren is way better than me, then the test is going to reject the null easier, because you're going to go out and watch us play, be like, he's destroying him in basketball, and you'll reject the false null, because the null hypothesis right now is Brian's basketball skills are the same as his brother's basketball skills. This is the null hypothesis, like just written in a non-statistical way or without statistical notation. The null would be that our basketball skills are the same, and if Darren's way better than me, i.e. a big effect size, then it's going to be easy to do this. But if there isn't much of a difference, like let's say the difference is very small. So let's say there is a difference. So is the null right now true or false? There is a difference, but the difference is very small. Is the null true or false right now? And I just want to repeat this. There is a difference, but the difference is very small. Let's say there is a difference, but it's very small. But no, there is a difference. So be careful. So there is a difference, but it's very small. Let's say there is a difference, but it's very small. Then the null would be false, right? So there is a difference right now. We're saying Brian and Darren are different in their basketball skills, but it's a very small difference. It's very small. Yeah, don't worry, I died 100 points. Don't worry about that. So with it being a very small difference, it would be what to detect that difference. Now, the effect size is the actual difference. So if there's a very small difference, it would be very what to detect that difference and reject the null. It'd be harder, exactly. So the test would actually be not very what. It'd be very, very hard. So great job, Kelly, there. Like it doesn't. So the test, it would be very, like it'd be not that what of a test. It'd be hard to detect the difference. And we'd say the test is not very what. The test is not very what. The test is not very what. Not accurate. Not look to the powerful. It's not very powerful. Does that make sense? It can't detect the difference. It can't reject the null because the difference is very small. But what could you do to be able to reject the null? Like, how could you possibly figure out this difference between Brian and his brother that's very small? You could do what to make your test more powerful? Because even if there is just a small difference, you could do this to increase the power of the test. And Catherine, great job, great practice right there. More points. You could do this to increase the power of your test. What could you do to increase the power of your test? So you're like, well, there's a very small difference between Brian and his brother. It's going to be very hard to detect that. It's not a very powerful test. So we could, but that is correct answer. You could go to there. You could technically do that. I wouldn't do that. We don't usually manipulate alpha. That is a true statement. You could increase alpha. You could watch more, which goes to when we have a larger sample size, the test is more powerful. So this goes to the sample size. And this right here was true. I should mark my answers as I do them. That is a true. This one is also a true. Sample size is n. As we increase the sample size, the test becomes more powerful. So we increase the sample size and we get a more powerful test. We're just watching them play more basketball. And then it's like, I've got a better idea who the basketball player who is better because I've watched them play more basketball. And just try to relate this to what makes sense in your world. You're going to have a better idea of the difference between Darren and Brian if you watch us play more basketball. If you watch us for like a moment, you're like, I only saw them for a moment. I really don't have a good amount of data to make this decision off of. I should probably collect more data. And that'll make the test more powerful, and it's easier to reject the false null. Type 2 error is related to beta. Well, let me change it. So what do you think about this third one right here? I mean, I just didn't once again, these are not curated questions to be perfect. They're me just coming up with them off the top of my head. That is a true statement. And probably one of the best ways to remember this is our little trick by writing them down. When we write down, we count with numbers. We go here and say 1, 2, A, B, plus, minus. And so exactly, Kale, 100 points right there, knowing your 1, 2, A, B, plus, minus. And that's to say a type 1 error is related to your alpha. You want to know what your type 1 error rate? Look at your alpha. You want to know your type 2 error rate? You have to calculate beta. Because while type 2 is related to alpha, it's inversely related. What do you think about the next question on here? Don't crash word. What do you think about the next question on here that alpha and beta are complements of each other? So the idea of alpha and beta being complements is a what idea? It's very false. This is a false. Oh, the plus minus? That's to say, usually when we talk about a type 1 error, and this is contextual, but usually I think of it as a false positive. There's one person who disagrees. I like to call it a false positive because you're saying you have evidence when you don't. And they are inversely. Great job, Kelly, right there. So the plus right here, because I always ask people to give the numbers, give the letters, and then say the sides of a battery, the sides. Because I don't know, I can't do the D's well enough because people say like A, AAA, AA, single A, I don't know, C, D. Why do we give them letters? Why don't we do like how many? I guess they're volts, right? It's too complicated then, right? So a false positive is a type 1 error usually. I guess let's talk about this just briefly here on type 1, type 2 error. So type 1 error. Who can type a definition? And then we'll explain why it's a false positive here in a moment. So remember when you do your definition of a type 1 error, you look and you say type 1 error. So you can quickly memorize the definitions of these if you practice along with this right here and you use our cheat sheet, which is right here in front of us. When we talk about a type 1 error, boom, and then you mention the mistake we make. Kale, 100%. And Kale, like, you might be the point where you're not even like using the cheat sheet anymore. And great job, Mohammed and Demetrius right there. In a type 1 error, the null is true, but we reject it. Because if the null is true, we shouldn't reject it. The null is a true statement right here. So in a type 1 error, the null is true. And that's what we're doing right here. We're always talking about the null. When we say in a type 1 error, the null is true. And then we make the error of rejecting it. And we reject it. We'll talk about why it's false positive here. In a type 2 error, and this is the practice, maybe it's the first time seeing it. In a type 2 error, the null is tell me the letter I'm forming. I've had people ask, what letter is that? Just think if I'm saying here, we're playing charades, and I'm like, what letter is this? In a type 2 error, the null is this. And I'll explain what the letter gives the hint of what we're talking about. The null is this. So what letter is this? There we go. I shouldn't look at the camera because then I'll like bend improperly. In F right there, Demetrius 100 points. In a type 2 error, the null is false, and we fail to reject it. In a type 2 error, the null is false, and we fail to reject it. You do 2 Fs for the type 2. Thank you to Hannah who came up with this. The null is false, and we fail to reject it. So remember, we are literally making these letters to memorize it, and we always talk about the null. Don't talk about the alternative or stuff like that. In a type 1, the null is true. That's when you do the T right there, and we reject it because that's an error. If the null is true, we should not reject it. In a type 2, the null is false, so you even got 2 Fs for the type 2. Best way to memorize it. Huge shout out to Hannah right there who came up with this. I can't take full credit for it. But no, she was just like, check this out. I figured out a way to memorize it, and I was like, oh my gosh, that's perfect. In a type 1, the null is true and we reject it. In a type 2, the null is false and we fail to reject it. Once again, a lot of my students come up with stuff and have helped me came up with these ideas for like memorizing these concepts and making them easier. So what do we think about here with a false positive? Let's say my fire alarm goes off. Is my fire alarm looking for evidence of fires, or my fire alarm looking for evidence of not fires? What do you think my thank you so much, Taylor. What do you think my fire alarm is looking for? Is it thinking at all times, I need evidence of not a fire, I need evidence of not a fire, or is there evidence of a fire right now? With my fire alarm, the null hypothesis would be what? With my fire alarm, the null hypothesis would be, and Kelzon says, yeah, exactly, because that's what I asked. The alternative, which is the evidence-based one, would be there's a fire. The null is that there is no fire. The alternative is the evidence-based claim. So when we say, we need evidence of something, we're talking about an alternative. So the pretty much, if you think about it as a statistical test, it's testing the environment around it to see if there's a fire, and it has the current belief that there is no fire. Does that make sense to everybody right here? So all of a sudden right now you hear, I don't have a beep, beep, beep noise. Here we go. But we're going to literally do this. You ready? Here we go. Oh, geez. Oh, no, that's... oh, no, that's going to be so loud. Okay. I just want to do this so... Okay. I'm going to do it right here. You ready?
Is your smoke detector chirping and driving you crazy? What type of smoke detector?
He didn't play it chirping. Oh, darn it. He's not showing the chirping noise or the beeping noise. Well, that's a bummer. Anyways, what would happen if we heard that beep, beep, or the beep, 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 and I say, hey guys, I gotta go. My fire alarm's going off. Something's going on. I gotta go check on the bunnies. Let me go. Oh, I guess I got back. That was a type 1 error. Oh my gosh, that was a type 1 error. That was a false positive. So what are you thinking right there? I know, right? I couldn't find it. If I say that was a false positive on my smoke alarm, what would you think? I should set that up for next semester. If I say that was a false positive, that was a type 1 error, what does that mean? When I say it was a false positive, my smoke alarm just had a false positive right there. So tell me this. What was true when I said there was a false positive? So just talk to me about this like you're be like, oh, Brian's saying there was a false positive, which is a type 1 error. I should probably. It is true. Demetrius, right. It is true that there was no fire. But what did so Demetrius, you're totally right. There was no fire. Exactly. So what happened is my smoke detector, my fire alarm did what? My fire alarm did what though? It did what? Exactly. Because, and so Mohammed, you're right. It did what? What did my smoke alarm do? Because it had a false positive. It had a false positive because it did what to that null? And just look at the type 1 error. It made a false positive. It whatted the null. It and so statistically speaking, everyone's right here kind of conceptually, it rejected the null and it said there's evidence of a fire, so there was a false positive. Now, what would you prefer? Would you prefer 2 false positives or 2 false? I'm going to give you the choice right here of would you prefer 2 false positives or 2 false negatives with your smoke detector while you're sleeping? Oh gosh, sorry. And yeah, woo! Who would prefer, let's see, you can just go 1. Who'd prefer 1 false positive or 1 false negative with their false detector while sleeping? With their smoke detector. What would you, did I say false? What would you prefer? 1 false positive or 1 false negative? Yeah. In this example, it's contextual. I would 100% prefer to have 1 false positive over 1 false negative. Because why? And false negative is very scary. My grandfather was a firefighter, so false negative is very scary. Because in a false negative, the null is false. So you look at this right here, and this is a false statement. The null is false. But, so that means what? If the null is false, what's going on right now? If the null is false, what's going on right now? And this might go to how they make fire detectors, because you think sometimes you'll be cooking something and it goes off and you're like, pfft. It's more likely to have a false positive than to have a false negative because, ooh, the null is false. Fire right there. Reese is right. That means the null is false. There is a fire, but we fail to reject the null, and this is why this is a false negative. Your smoke alarm, smoke is all around it, and it's not going off because it's like, nothing's going on. And you're like, are you crazy? This is a false negative. There is a fire. The null is false. There is a fire. This is a false statement. There is a fire, but I'm going to not reject this null. So in a false negative while you're sleeping, scary things right here, but this is what we have to think about in manufacturers. We probably would make our fire alarm more likely to give false positives because a false negative could cost someone their life. A false positive is rather annoying, maybe a little bit scary too, but a false negative is life-threatening. So what is the cost benefit? Exactly. You're just chilling at a party and your house is burning down. So this is rather scary stuff and what you have to consider. And you might hear these terminologies if you work for a company making smoke detectors. They might say, exactly, better safe than sorry. So you might err on the side of false positives. This is the context of like how we use this stuff right here with type 1, type 2 error. People might not even call it a type 1, type 2 error, but they might say, we have to make sure the smoke alarm, might go off a little more often because we'd rather have people be annoyed by it than lose someone's life. And then annoyed. Exactly, Reese. This is I love this. This is a great example, a little bit scary right here, but these are the real world examples of type 1, type 2 errors and why we might call it false positive, false negative. Thinking about Catherine and people asking, like, can we go over, like, why is it called a false positive? Positive, negative, false positive is more contextual. Type 1 error would be always, like, these are the literal definitions, but I do think of it more of a false positive. Like, you're saying you have evidence. So you're like, I found something, which I think is a positive, but you're wrong. That thing is not there. Whatever you're saying you have evidence of, you're wrong about. That context will always remain. In a type 1 error, you say you have evidence of something when you don't. I'm switching the definition a little bit, not trying to change what it is. But who understands me, yes or no? In a type 1 error, you would say you have evidence of something when you don't. Hence a false positive in my view always. Because how do you have evidence of something? You're rejecting the null. So it's still, you reject the null when you shouldn't. So you reject the true null. But in a type 1 error, you would say you have evidence of something when you don't actually have evidence of it because the null is true. Hopefully the concepts make more sense than a definition. The definitions can help, but then we try to understand, well, what does it actually mean? Really great stuff right there. I always love the applied version of what we're doing. Like, great stuff. We mentioned that alpha and beta are not complements. There are 3 things that impact beta. What are the 3 things that impact beta? Beta is power. More on that later. No, you're, Kayla, I want to say this. You are really understanding things at a way deeper level. And I always try to like teach at the different levels. Oh, Charlie, do I? Oh, you bet. Rewind the video. We were just doing it. 100% Charlie. So great to see her. Charlie joining in. So what are the 3 things that impact beta? So alpha and beta are not complements. That's such a false statement. The 3 things that impact beta are what? Well, we just mentioned effect size. And then we have sample size. And then Kayla mentioned the third, which is alpha. And they are all what to beta? So as any of these increase, they decrease beta. As any of these increase, they increase power. So what is a complement? Sample size, effect size, and alpha. And they're inversely related to beta. As any of these. All right. Stop autocorrecting me. I'm going to go with my own grammar. As any of these increase, they increase beta. Then power is 1 minus beta. More on that down here. So power is 1 minus beta, which is basically not making a type 2 error. Power is the ability to correctly reject the false null. And so, yep. Well, beta and power are the complements. So beta and power are complements. Does that make sense to everybody right here? Power and beta are complements. These 2 things are complements. Alpha and beta are not complements. This is a false statement. These are not complements. But I should put that in red or something, right? So alpha and beta are not complements. What are complements are beta and power. Power is the complement of beta. 1 minus beta is power. And like you were just saying there with P and Q, 1 minus P is Q and 1 minus Q is P. They're complements of each other. So good stuff right there. Kind of what terms are these? Make sure to review. We talked about effect size, sample size, and alpha a little bit earlier. When a confidence interval contains a value, we can reject that value on a 2-tailed test with 0 minus alpha level of confidence. I should have added in one more bit right here. True or false on this one? True or false on this crazy question? Let's see what hell. It is false. No worries. Good story there, Mohammed. Don't worry. 100 points, Mohammed. It is a very false statement. We're going. Which color? It is a very false statement. And I've written the true statement below. Once again, think about this. Let me tell you this much. Steak dinner will cost between $40 to $50. Just think about how we would apply these knowledge. Do you think, so if I tell you a steak dinner will cost between $40 to $50, sorry, I just love steak, everybody, and haven't had a good steak in a long while. I tried to make some steaks at home. They turned out okay. Not like a good Chop House steak. I don't know. Chop House is best steak out there? Yes, it is. Shout out to Chop House. Would you think it's possible that a steak that Brian's going to order could cost $42? Oh, Casey, you got this. You got this. Good luck on the exam, Casey. You got this. Who thinks it's possible that the steak could cost $42? Would you look at this? I think I'm 95% confident the steak I order is going to be between $40 to $50. What would you tell me about $42? This goes into wording towards the end. It's in the intervals. So we'd say, I can't reject that value. Now, here's the thing. we have not we would not say the words like I accept this as the truth or I've proven this is true. Any of these values inside of here are what truths? Think of it, fill in the rest of this word. Fill in the rest of this word. Any of the values inside of there are what truths, like to what the stake will cost. I think it'll be between $40 to $50. So that's the hangman game right there. Any of the values inside there, and that's why we don't say we accept them or we've proven anything. Those are just what values of truth right there. It'll be between $40 and $50. So any of those values right there are what values of truth. So think about what word am I trying to have you think of right here. That this is why we don't say the word accept and prove. We just say, well, $42 is what? $42 is a what value for what the stake could cost? Close. Possible. Yeah, possible value of truth. So it's possible. Like it is like that's why we can't reject it. If you think about the way we talk, I can't reject 42 because it's possible. Now, if someone says, "Oh, I bet your stake will cost $6," I would say what to that value of $6? So when someone says, "I think your stake will cost $6," I say, "Nah, that doesn't really seem possible to me. I reject the value of $6. I estimate it'll be between $40 to $50. I reject the value of $6 because it's outside my interval." So the interval gives us possible truths. I don't know how much the stake is going to cost. This is not real statistics right here. We're just using real world examples. I would doubt it. I would not. It's not very likely to be true. Exactly. And so we're like, no, from my experiences, the true cost of the stake when I go to the restaurant, because maybe we go to the restaurant over repeated visits. Now we have a sample size and we can estimate the average cost of our steak dinner. We could say, well, the average cost of my steak dinner is somewhere between $40 to $50. So when I go to the restaurant, the true cost of the steak dinner at the restaurant on average should be here. It's all possible. Well, it's all possible, but this would be, Kayla, great answer right there. This value right here is a very what value? It's a very, given our interval, which goes to the p-value of it, that is a very what value. Hence, if we got a p-value on this, assuming it is the truth, and looking at our result, it'd be a very low, and that means it's a very what likely possibility. Unlikely. So it is possible. So we should, you know what? I'm throwing 1,000 points. I actually agree more with Kayla than I do myself. Because all these values are possible. Anything is possible. But these are probable values. Reviewing everything right there, I would agree that these are the probable values, the likely values. So that 1,000 points goes out to Kayla right there. I actually agree more as Kayla and I are talking over this, that is a possible value of truth. But the probable values, the ones we would believe, are between 40 to 50. So I agree more with Kayla on probable than possible, because any value is possible by random chance. Some values are more probable, i.e. likely by random chance. Give shout outs right there, Kayla. Just when you are like getting more exact on my language. Yeah, no, I was looking at it, I was like, yeah, anything's possible. So probable is a better word. These are the probable, i.e. likely values, and that's the unlikely values, because that is possible. And so the ones we believe are more possible would be the probable ones. So shout outs right there. Great answers. And yeah, if you're correcting my wording, then you are on track for the final. And that's what I like. Because sometimes I come with these examples off my head. So sometimes like, that's a better way of phrasing it right there. Because all the values are possible. Some are more probable by random chance, i.e. p-values. Chi-squared test of independence is for two quantitative variables. Thoughts on that? Chi-squared test of independence is for two quantitative. I think we marked that last one, right? Yeah, we did. Chi-squared test of independence. They could. It's possible, right? Or you get a discount or something like that. The alpha. Okay, I can go back and Demetrius talk about that real quick. We'll do this one and then we'll head back down real quick. That's regression. Oh, great answers. Yep. False. CO2. Quantitative variables would be a regression. QQ. Straight enough. No outliers. To do the chi-squared, we need categorical y and categorical x. This gives us the condition of this meets the condition of count data. So that's literally a condition we use, two categorical. I'm so confused what the alpha means in that question. So this is false right here. Let me look at the alpha. So the 1 minus alpha. So this is a good quick question too. When we run a statistical test up here, it is 1 minus alpha. So this 95% confidence interval right here would be the same as doing a two-tailed test with what alpha level, which is the one we generally use. But since I'm making a 95% confidence interval, and so this goes to the previous question, it's the same as doing a two-tailed test with what alpha level. Look at the 95% confidence and use the 1 minus alpha. So what percent alpha am I using right here if I do the 95% confidence interval in the two-tailed test? .05. Does that make sense? So just 1 minus confidence. Did I make an error? Let me double check mine. Yeah, and then you can reverse it. So this right here is 1 minus confidence level is alpha. And let me make sure my brain's waking up. Yeah. The confidence interval will be 1 minus the alpha. Because let me ask you, so then we'll do the test right here can be 1 minus confidence level. So both are inversely related. So the test and the confidence interval can kind of work together. I want you to estimate, a little bit of an advanced question here. I want you to tell me about the p-value. Well, first off, just tell me. I'll make it easy. We'll do it step by step. Be very careful. This goes down to the decimal. Reject or fail to reject this value. Why or why not? Just look at the value right here and tell me reject. I'm kind of giving a hint by putting it there. Reject, and be very careful. Watch the decimals on it. Reject or fail to reject this value. Reject or fail to reject that value. Reject or fail to reject that value. And I'll tell you why. Reject or fail to reject that value. And it's close, but be careful. It's close. Fail to reject. Catherine, you're right. Why do we fail to reject? We fail to reject. And why do we fail to reject? Double check if you put reject. Why do we fail to reject? It's very close. It's very close, but it is fail to reject. Unless I'm doing it wrong. It's very close. It's very close. And so why do we fail to reject? Great job, Kylie, right there again to the rock star level. So why do we fail to reject? And this goes back to the previous true false. Because it is what? Why do we fail to reject? And it's just barely. Why do we fail to reject? Let's go back to the true false right here. We would fail to reject this value. Demetrius is right. It's in the interval, right? It's in the interval. And so think about this. We are testing this at the 0.05 level of significance. Can anyone, and you haven't seen it, I haven't seen it, can anyone guess the p-value? Because I'm saying we just barely fail to reject. Who can guess the p-value? And so remember, we are just barely failing to reject because it is in the interval. I believe it is, Kayla. Double check. It's just barely in it. It is just barely, because this is beyond it right here. The next decimal is an 8, so it's just barely in there. That's a trick. Oh, yeah, no. Yeah, no, so I think you knew it conceptually, so great job right there. 100 points, everyone. Who has a guess of the p-value? Yeah, you might have reversed your eyes right there. I do that all the time. So it is just, you were conceptually right, so you know the concept, you saw it wrong right there. So who has a guess of the p-value? You're like, I can guess the p-value? Well, we're saying we just barely fail to reject. We barely fail to reject. Use that knowledge of we barely fail to reject and guess the p-value. And you'll be shocked. You might get really close if you know we barely fail to reject this at the 0.05 level. That's the big hint right here. Little teaching towards top of knowledge right here. But you should have a guesstimate of the p-value if you say, well, we're just going to barely fail to reject this, which is still fail to reject, but just barely. I'll put my guess in the chat once one person writes this. If you beat my guess, another 500 points. Ooh, Kayla and I are competing with two p-values right here. Now, remember, Mohammed, we just barely failed to reject, so the p-value must be over 0.05. That's the key thing to hear right there. Since we barely failed to reject, the p-value must be greater than 0.05, and I'm still throwing it. It's between Kayla and my answer, or Kayla, your first answer right there, and we're looking at the two-tailed test, and so I'm throwing those 500 points out here. We just barely failed to reject, and Kayla and I did win. Oh, wait, yep, I did win, Kayla, but just barely. So both of us were very close in our guess of about 6%, about 5.5%, because we just barely failed to reject. Does that make sense? So at the 0.05 level, we cannot reject this on the two-tailed test. The two-tailed test is the does not equals test. Because the tested value of 3.835 is contained in the interval, we cannot reject it at the 0.05 level of significance using the 95 test. So use your knowledge. We just did again, and now tell me the p-value for this one. So be very careful, and I'm going to give a hint. Tell me the p-value for this one, and maybe I'll throw on a little there. That's even better. Tell me the p-value for this one. Like, just give me a guess of what the p-value is. And then just think about, I'm giving a hint where it's at. I'm like trying to show you visually a hint. But this is the same knowledge. Like, the most rudimentary knowledge is we can what that value because it's what. This is what we should know first off, is we can what this value because it's what. The test will not have you guessing p-values, but it's a good knowledge thing. I'll be careful, Catherine. I'm going to try to think, but look at the value right there. You're covering... Oh, so yeah... it's the upper and the lower. Oh, sorry. And I'm trying to show that it's this right here. I'll be careful. That is that inside the interval or outside the interval now? This is the base knowledge right here. Is that value inside the interval or outside the interval? This is the starting point, which we should all know. Is that value inside the interval or outside the interval? Be very careful. You have to look at the decimals. It's outside. So we can what that value. So now this is the next step. We can what that value. So since it's outside the interval, we can what that value. So that value is outside the interval, right? We can reject it. Okay, good work right there. And so we can reject it, which means the p-value must be what to alpha. So next step, since we can reject it. So Catherine, does it make sense? This value is outside the interval. It's beyond that upper right there. It's above it, just barely. So since it's outside the interval, we can reject it. So the p-value must be what? Less than 0.05. Does that make sense? Does it make sense? Like, we're just going to barely reject this. So the p-value is going to be just barely below 0.05. Does that make sense? So it's going to be lower than 0.05 because we're just barely rejecting it. So all those guesses right there, people are great. It's about 0.04 something. I'm throwing another 500 points. Those are good enough guesses. I should have gone with my first thing because that probably would have been a lot closer because we're just barely rejecting it. But you were very close. You said about 4% something. You were right. We're just barely rejecting it because it's just barely outside the interval. So the p-value is just barely below 0.05. This was, once again, a little more like we went through the basic concept of when we reject something, we reject it when it's outside the interval. And what does that mean? Well, the p-value for the two-tailed test will either be above 0.05 or below 0.05 if we're using 95% confidence intervals and kind of showing more examples of this. It's about as low level to high level I can teach that concept. Always try to let people see it at different levels of understanding because sometimes those high levels can help you cement your knowledge. But yes, most basic of level, if something is inside the interval, you cannot reject it towards the upper level we were talking about right there. Two sample t is when both variables are quantitative. No. When do we see the two sample t? So once again, we could copy this first thing right here. And there we go. Two sample t is when we analyze a quantitative y because means, and we break it apart into two groups, which is categories. Categorical and quantitative, yep. And so the categorical will be on the x. So if you put it on the y, you get some logistic regression. Quant and cat, exactly. So you're basically just saying you have two groups and you're comparing the two means. Try to think of the questions as like, well, what am I doing in the two sample t? I'm comparing two means. So I need a mean for this group and I need a mean for this group. Let me compare the heights of, freshmen versus seniors. So I have two groups. So that's very false. Statistical power is beta. True or false right here. Talked about this earlier. I like to put review questions on these to just make sure we see like, is statistical power beta? Is that a true statement? Sheet. Is statistical power beta? Is actually... Yeah, it's the complement. Great job, Kayla, right there. Another 100 points. It's the complement of beta. It's 1 minus beta. So it is, which is 1 minus beta. So it's the complement of beta. So basically not making a type 2 error is statistical power. So this is another false statement right here. Statistical power is not making type 2 errors, which is 1 minus beta. Beta is the probability of a type 2 error. Statistical power is not making type 2 errors, which is the ability to reject the false null. We talked about this earlier, so another review is the so type 1 error is worse than a type 2 error. Funny enough, we just did an example where it wasn't worse. Oh no, it's a beta here, Catherine. I can review. This is false. I'll review that. Catherine, can you expand upon that? And I'll go. Wait, so it's just power complement of alpha? No. So remember, alpha and beta. Just to review again, real quick. Alpha and beta are not complements of each other. Alpha and beta are inversely related. All of these are inversely related right here. So as any of those, as any of these increase, they decrease beta. So all of these are inversely related, but so this is false right here. They are not complements. As alpha increases, beta goes down. Does that make sense right there, Catherine? As alpha increases, beta goes down. As sample size increases, beta goes down. As effect size increases, beta goes down. And then as these increase, they increase beta increase power, excuse me, because power is 1 minus beta. So, but none of these are complements except for beta and power. Like power is 1 minus beta, so it is the complement of beta. So does that make sense of a type 2 error? Does that make sense? And people are giving the great answer, Carly and everybody. People are mentioning the context. Check to our fire alarm example we talked about earlier. Yeah, expand upon, Catherine, get more questions. Thank you so much, Catherine, everybody asking all these questions. I appreciate it so much. Let's ask another one. Type 2 error is worse than a type 1 error. Remember that smoke alarm example where we said the type 2 would be worse? So what do you think about this? If you remember back to our smoke alarm example where we said the type 2 would be worse, it was worse in the smoke alarm example. But put that word in the chat again that Carly and everyone's putting right there. Also false, yeah. It can be worse. Let's, ooh. This, I wouldn't love these questions. I wouldn't love these. But this really points to the concept right here. Wouldn't love these questions. What are people's thoughts on these two? And this really points to the reasoning behind it. So what are people's thoughts on these new question? What are people's thoughts on these? Type 1 error can be worse than a type 2 error. Type 2 error can be true for both now, yeah. That's really the meat of it. It's all context. Every one of these is context. It's possible for the type 1 to be worse. It's possible for the type 2 to be worse. Type 1's not always worse. Just what are we talking about here? What is the cost? That's what a company would look at. So all of these depend on context. There are instances when one is worse. So I think to all the times people have asked questions about their test where they're like, I thought you said it's not that one is worse. It's like, well, it depends. Check out our fire alarm example earlier where we talked about your smoke alarm going off, alerting you there is a fire. And we did this example earlier. So in this example, we pretty much all agreed that a false negative, sleeping through a fire would be worse when your smoke alarm fails to find the fire. Now, for the context of this one, we would want the type 1 error where we're woken up to a fire that is not happening. And then the type 2 in this instance would be not getting alerted to a fire that is happening. So the context of this one, yeah, if you want your house to see, that's the thing is we will get answers on test in written format like, I don't like my house. I don't live there anymore. I'd prefer a type 2 error happens. And we're just like, usually a student who's doing really well in the class, like, will come up with something like that. It really depends, right? Like, probably I'll just mention this briefly. Like, one of the craziest things we wrote was actually goes to a Kahoot question I wrote. You have a tree in your yard that looks like it might be dying. The null hypothesis for all trees are that they are healthy. The alternative, evidence-based, is that the tree is dying. This is a real question we wrote in longer format. If the tree falls, it'll hit your neighbor's house. And that was the fatal flaw in this question. Neighbor's house. Which error would be worse to make? And so just go through this here. Tell me, as most students would answer, unless they're overthinking the question, take a moment, tell me which error would be worse to make and why. We also want, justify your reasoning. You could just say which one, type 1 or type 2, and then I'll give the answers like what students gave. So at least one student outthought this question. We had to pretty much give points to be like, well, interesting. Oh, celebrate Jota reason. So you have to know the null hypothesis here, the tree is healthy. We'll see what people think. We'll finish off the true false and probably take a break. Might come back later, never know. Never know. And 320, 474, 475. Type 1 error is better. Like, you'd prefer the type 1 error? Go to a second or two more. We'll see what people think, and then I'll answer the question. So identify the null hypothesis. So the null hypothesis is that the tree is healthy. In a type 1 error, the null is true, but we reject it. I probably agree with Mohammed right here. Does everyone see right there? That's the full answer right there. Yeah. Oh, wait, but no. If you do it the type 1, though, you chop down your tree. No, that's all right. Look at the null and always be like, the null is true for the type 1. The tree is healthy. So, Kayla, you're going towards the type 2 right here, which was the answer we got from some students. In a type 2 error. In a type 2 error, it is false. The tree is healthy. The tree is actually sick, and we leave it up because we do not reject the null that it is healthy. I don't care about my neighbors. I'll leave my tree up and then blame them. Yeah, I don't know, like, that's the kind of answer we got from somebody. They obviously understood it, so we had to give them full points. But we were going towards the idea of, like, it'd be a better idea to chop down the tree. But if someone outthinks the question in a type 2 error, it is false that the tree is healthy. Like, the null is false. In a type 2 error, the null is false, but we fail to reject it. So we're going to retain the null. We're going to believe it's healthy. So the tree is actually sick, and we leave it up. It's a false statement that the tree is healthy. The tree is actually sick. Because we do not reject the null that it is healthy. I don't care about my neighbors. I'll leave the tree up and blame them for it falling. Like, that's the kind of answer we got right there, which is like, well, you understood the concept. We kind of give you the points because you have communicated what a type 1 and type 2 error are in these contexts. You get full points. That's the way it rolls. Yeah, we just want to make sure you know what these concepts are. When we reject the null, we prove the alternative. Ooh, what do you think right here? Help me out with this. We'll end off here in about 5 more minutes. What do you think right there? When the type, we reject the null. I am catching up on sleep. When we reject the null, we prove the alternative. False. You don't you say these words. We have evidence for the alternative. We never know. We don't know for certain. We can't say we know things. We can't prove things. It's the word prove, and also the word cause are bad words. You don't want to say prove or cause in statistics unless you're running experiments. We didn't teach you experiments, so how could you possibly run an experiment? We don't say the words prove and cause. Causation can be shown through experimentation. Really good stuff right there. A lot of scientists are going to use experimentation to say we see some causation right here, and that's going to go to designed experiments with randomization and elements of control with changing things. So really on our test, since we didn't cover that, you're not going to see proven cause right now, because unless you have a very high gold standard of experiments, you're not going to go towards those words. Even then, I wouldn't say prove. We have a strong causation link between these. I'd probably say I wouldn't say we've proven this. We have a good understanding from this experiment that shows evidence of causation. That's only in the experiment world. Someone's going to write, he said evidence and causation only in the world of experiments, which we didn't cover. Take a design of experiment class. Great stuff. Last but not least, what do you think on this one? When we reject the null, we accept it as when we, now it's got to be true, right? When we fail to reject the null, we accept it as true. True or false? When we fail to reject the null, we accept it as true. Thoughts on this? Everty in the chat. Wake up! Oh no! Don't worry, Catherine, 100 points. I tricked you. Accept is the bad word. Don't say accept. We won't accept it as true. We're just saying what here? Oh, I tricked everybody. I like that. 500 points for tricking everybody. Don't worry if you got it wrong. We don't like that accept word. We would just say the null is a what value? I'm not saying I accept 42 as true. I'm just saying I think $42 right here for the price of the steak is a what value of the steak. I'm not accepting it as the true value of what the steak will cost. I'm not saying it will cost $42. I'm just saying that's a what value. I'm not saying I accept that 42 is the truth. I'm just saying 42 seems very what to me by not rejecting it. I'm not accepting it as truth. I'm just saying it seems very what to me. Like, yeah, that's very what. 42 is a very what value. It's a very probable value of truth. So it's inside my interval, i.e. we would not reject it on the tests. So it's a very probable value of truth. Now, when you reject, likely, I like that right there. 100 points right there, likely. I like that because that means high p-value. So i.e. don't reject the null, fail to reject the null. High p-value, a very likely, probable basically means likely too. My computer, no, okay. And then over here, we have a value we would reject. And we reject because there's good evidence to say that it's unlikely that the value of the steak will be $6 when we go and buy our steak from the place, or on average, we should say. And so we'd reject the value of $6 and say there's good evidence to suggest. Now, we're not saying we've proven that the steak won't be on average $6. We would just say there's good reason to not think that. We have good evidence to suggest that. We can't say we have proven or we know this or this is for certain. We just have probable values and not so probable values. I think that's got it. Great stream today, everybody. Well, I might stream later, probably stream tomorrow, but how are people thinking? And I want to give a huge shout out to the Discord. Let's hop over to the main screen. I really mean this. Like, I want to play this one. People are on the Discord right now answering each other's questions, helping out. Don't worry. Like, I'll tell you this much. I didn't make all A's. Like, I think some people are going to make some A's in here. If you're here right now, if you're practicing, feeling a lot better, like doing that, awesome. I didn't make all A's in college. You know what matters more than A's, and I mean this, and not just like here in class, but relationships. It matters more about the relationship with your family, your friends, the people in your life that matter, and that carries over to school. If I'm going to give you one last bit of advice here, it's not going to be on the test. If you're in the Haslam College of Business or any college at UT, or if you're just watching this stream for fun, if you want to get a job, that's what we're going towards, and you see someone that has some College of Business, talk to them. Like when you see Eastman there, or Pepsi there, Frito-Lay, you see Tremel there, you see Pilot, and they're looking out. Just go talk to them. We're not playing the music? You should hear the music playing through. But yeah, you got this. Kayla, you got this. Trevor, you got this. Reese, you got this. Come in with that positive attitude. Test is going to be tough. We don't have the written portions grading when you do it. But the more you study, the better off you're going to be. And then if you make a B+, if you make an A-, if you make a B, a lot of people make a B in Stat 1. That's okay. What matters more is that you're reaching out. You got this, Kylie. Just, it's not really cumulative, but the topics kind of converge. Like there's like, someone be like, well, I don't need to know what the mean is because we learned that early on. You're like, no, we're doing confidence rolls for the mean now. Make it happen. Don't get that B. But then realize this. If you do make the B, Brian made a lot of B's. I made a lot less than B's too. I'm very happy with my life, and I don't let those B's define me. What mattered more than all my grades was one night when I decided to go to Headphone Disco and meet a girl named Chelsea. That's what mattered more than every single grade in a class, was one night and talking to somebody. That one night and that one conversation matters way more. Remember that if you take advantage of the opportunities, if you're thinking of doing something, if you're like, I'm going to go and talk to that company, that might be the company you end up working for. You never know. Maybe it'll give you a connection. Thank you. I mean it. Like, it matters way more the connections we make and the people we help in our lives, but still make an A. Thank you. Thank you right there, Demetrius. I'm glad to hear it's more enjoyable than calculus. We're here to have fun. Puppet Shark, did you have fun today? Puppet Shark. No more sadness. We still got. I'm not gonna play. Let's play sad outro music, but let's do our effect that we never do with it. It's time, everybody. We're gonna fade out here. We'll be back next time, maybe later tonight. You never know. Bye for now, everyone. Bye. Slow camera out. See you. Bye. That is awesome, Casey. Shout outs to Casey's boyfriend right there. Bye, everybody. Just making sure the stream's ending.